Hello students, today's agenda is to learn about the point slope formula. You will be able to work on 10.10. Today students will be able to find the equation for lines given a point and a slope, and also to find the equation for lines that are parallel or perpendicular to another line given a point. Okay, and so we're gonna use this formula, which is called the point slope formula, but I want to show you where this comes from. Okay, and so what do we know? What we know is that the slope is equals to y2 minus y1 over x2 minus x1. That's what we used in the previous lesson. And so what we're going to do is we're going to multiply both sides by x2 minus x1. And so we're going to multiply by x2 minus x1 on both sides. And this cancels. And I end up with x2 minus x1 times m, which is the slope, equals y2 minus y1. So that's just by multiplying. Again, this was the slope and we multiply that to cancel this, and this is what we end up with. Now look at this and look at the point slope formula, which is the one that we're going to be using. Okay, this is what we need to remember. What is the similarity between these two? Well, you have y2 minus y1 in here, except that you don't have a 2, equals, you have the slope in here being multiplied by x2 minus x1, except that you don't have the 2. And why is that? The x2 and y2 come from having a second point, but in here we're going to be given only one point. So that's why it doesn't have the 2 or the 2 for x and y. Okay, so this is what we're going to be using. That's where it comes from. It comes from the slope. And the first prompt or the first exercise says, find the equation of a line passing through 2, 5 with the slope of 3. And so we're going to use the point slope formula, which is y minus y1 equals m times x minus x1. And so this is going to be x1, y1. And again, we don't have a second point. That's why we don't put the 2's in here. And the slope is represented by m. It comes from the equation, if you remember the slope intercept, y equals mx plus b. Y equals mx plus b, where b represents the y-intercept, or if you recall, is when you're graphing, is the initial point or the first point, and the slope represents the rise over run, meaning the slope. Okay, or if you remember, is the sun over the runner. Okay, so those are the things that, if you recall, that's where the m comes from. That's what it represents, the slope. So in here, in the word problem, it says slope of 3. That means that my m is 3 and the point is 2, 5. Now that we have that, we're going to write y minus y1, it's 5, equals m is 3 times x minus x1, which is 2. So all you did was to replace the x1, the m, and the y1. The m is the slope, the x1 is 2, and y1 is 5. Okay, so that's what you replaced in there. Now that we replace it, we do distributive property, and so y minus 5 is equals to 3 times x, 3x. 3 times negative 2, negative 6. The last step is, if we're subtracting, we're going to add 5, and that's to leave it in this format, y equals mx plus b. okay? This cancels, and y is equals to 3x, negative 6, positive 5. Remember that different signs we subtract and leave the sign of the greater one. So it's going to be 6 minus 5 is 1, and the greater one is negative, so we put negative 1. Now, for the homework, you don't have to graph it, but I'm going to show you the graphing here, a tiny graph. And it will be better if you have graphing paper, that's going to come out better. So the initial point, which is the y-intercept, this is always the first point, okay? Is the y-intercept, first point. And it's always on y-intercept. So I'm going to put 1, 2, 3, 4, a couple of them here. Okay? So the slope is always a rise and run, and if it doesn't have anything, you just put it over 1. Remember, this goes up or down, and this one goes left or right. So my initial point is at negative 1, which is right here on y always, and that's when y is isolated, okay? And then 3 is positive, so you're going to rise 3, so 1, 2, 3, and 1 is the run, so right there. And you can repeat the slope if you want. 1, 2, 3, 1. And you can see that this point is actually at 1, 2, 1, 2, 3, 4, 5, which is passing through 2, 5. And so my line, more or less, is going to go through those 3 points. My straight line, okay? Again, for the homework, you don't have to graph it, but that's how it would look. Okay, the next one says, using the equation y equals 3x minus 5, find an equation that is parallel and passes through the point 3, negative 2. So there are several things here. First of all, you need to know the slope. Okay, the slope. The slope is m. Remember that we can find it in the equation because it's in the format of y equals mx plus b. And in here, the sign just means that it might be positive or negative, okay? But the slope is that number right there, the coefficient of x. So the slope for this line is 3. The other thing that we need to know is that parallel lines have the same slope. Okay, so actually if this is 3, this is also going to be 3 because we're finding parallel line that passes through that point. So that's going to be the point that we're going to be using because it's telling us that it passes through that point and that is parallel to that line. So the slopes of parallel lines have the same slope, so the equation that we're going to find has to use that same slope. Okay, so again, we're going back to this point slope formula, and I'm going to leave it there. Actually, let me write it again. So it's y minus y1 equals m times x minus x1. And since I already know that the slope is going to be the same because there are parallel lines, and that point is the one that we're going to use, that's going to be our x1, y1. So we now can replace all that information in the formula. So y minus y1 is negative 2, put it between parentheses. If you don't put it, that's fine, but some people prefer to put the parentheses. The m is 3x minus x1, which is 3. Okay, it comes from here. After that, we can do two things at the same time. We can do distributive property, and also remember that this negative times negative becomes the big plus. Okay, two negatives together, big plus. And so that becomes y plus 2 equals 3 times x, 3x. 3 times negative 3, negative 9. And so if we're adding 2, the opposite is to subtract 2. And so y is equals to 3x minus 11. So that's the equation. And the first equation that they gave us here in the problem is y equals 3x minus 5. So I'm going to write it right here. Y equals 3x minus 5. And the reason is because, again, I want to graph it. I want to graph both of the equations and show you that they do form a pair of parallel lines. Okay, remember these are two different equations. And so, again, I don't have, I'm just going to do a sketch here because I don't have graphing paper. But it's going to be -1, -2, -3, -4, -5, -6, -7, -8. Notice how this one is wider than this one, so that's not good. 9, 10, 11. I'm just doing up to -11. So let me graph this one first. And it doesn't matter which one you graph first, but -11, and then the slope is 3/1. So -11, we already know that is all the way here. That's my initial point, because some people like to say, oh, that means that this is y, y, x. If you want to see it that way, that's fine. But this is my y-intercept. This is the rise, meaning the change on y, and this is the change on x. That's why they call it like that. So -11, my initial point. Then, since it's positive, you go up 3 spaces and 1 to the right. So right there. 1, 2, 3, 1 to the right, 1 to the, and so on. Okay, so that's my line. The other one, this one right here, which they gave me in the problem. Okay, some people were asking, where does that -5 come from? This exercise that they gave me. Okay, so it's gonna be -5. So 1, 2, 3, 4, 5, right there. Remember, it's y, y. And then if there is no run, you put it over 1. So initial point, 1, 2, 3, 1. Okay, 1, 2, 3, 1. And so more or less, that's my parallel line. Again, this is a sketch, and it's just that I don't have my graphing paper. But notice how the lines look like they're never going to meet, okay? Okay, let's look at a third problem. And so, now, this problem says, using the equation y equals 3x minus 5, yes, it is the same problem, the same equation. Find an equation that is perpendicular. And so, oh, and that passes through the point 3, -2. Again, that's the same point, but the other one said parallel, and parallel lines have the same slope, okay? But perpendicular lines, I don't know if you recall from the previous lesson, perpendicular lines have opposite, meaning it changes the sign, opposite reciprocal, meaning they change the numerator and denominator, they change. So opposite reciprocal slopes. Okay, so you're going to change the sign and you're going to change the numerator and denominator. Again, this is y equals mx plus b. The m is 3. Okay, for this one. But we don't want that slope because otherwise that's going to give me a parallel line. What I need a perpendicular to that line. So I'm going to change, if this is positive, negative. That's the opposite. Reciprocal, since it doesn't have a fraction, you put it over 1 and you swap them. Okay, so instead of 3/1, it's going to be 1/3. And for the point, again, is 3, -2. We don't change anything about that one. Okay, just the slope. Okay, so now we have that information in there. we're gonna start with the formula, which is y minus y1 equals m times x minus x1. And so y minus, again, this is x1, y1, it's -2. The slope is -1/3 times x minus x1 is 3. This becomes the big plus, and it makes it's so big that it makes the two minuses disappear. So it's y plus 2 equals, we do distributive property at the same time, so -1/3 times x, -1/3 x. Negative times negative is positive. And let me tell you a trick. So whenever you're multiplying a whole number or integer and a fraction, you can just multiply the whole number or integer times the numerator, and the result you divide by the denominator, especially if this is a multiple of that, meaning 3, 6, 9, 12, 15, 18, all the multiples of 3, you can just multiply by the numerator and divide by that, and you will get a whole number. Now, if this is not a multiple, what you're gonna do is multiply it and divide it by that, and you get a decimal. Okay, so again, negative times negative, positive. 3 times 1, 3. 3 divided by 3, 1. Or if you want to do the other way, is -1/3 times -3. You put it over 1, and then you multiply straight. Negative times negative is positive. 1 times 3 is 3. 3 times 1 is 3. And 3 divided by 3 gives me 1. Okay, that's where it came from. And I should have done it a little bit to the more farther from that, but that's okay. The last step here, we don't want to leave y with something else. We need to get rid of that 2. And if we're adding 2, the opposite is to subtract 2. So y equals -1/3 x minus 1. So that's my equation for the line that is perpendicular to that other equation. Okay, so that equation and these equations form perpendicular lines. So let me show you again in the homework. You don't have to do it, but if you want to, you can. I saw a couple of students doing the sketch just to prove it. Let me copy that. So that's the first one is y equals 3x minus 5. Okay, that's the one that they gave us in the problem. That's how much I need only. Okay, so it's the initial point is -5. So 1, 2, 3, 4, 5, that's my first point. And the rise and run, if you recall also the sun, because sun rises, it goes up if it's positive, down if it's negative. And then the runner, it goes right if it's positive, and left if it's right if it's positive, left if it's negative. So initial point, -5. The rise is 3, 1, 2, 3, 1 for the run, 1, 2, 3, and 1 for the run. So more or less, my line is like this. And for this one, the initial point is -1. Okay, that's the y-intercept, my first point. And then this is my sun. Since it's negative, it's going to go down. And this is positive, so it's going to go to the right. So from the initial point, down 1, and then 3 to the right. So 1, 2, 3, right there. If you notice, the lines for perpendicular lines, meaning they form 90-degree angles. And so that's it. Now you can work on 10.10 and have fun.